Hello everyone, my name is Sai Kumar Shilam. Today I will be presenting my project on stock price predictions using machine learning and learning. The main goal of this project is to predict future stock prices using historical data and advanced models like random forest and LSTM. Stock price prediction is important in finances because it helps investors to make better decisions, reduce risk, and understanding market trends. In this project, I performed data analysis, future engineering models, and finally deployed models using web applications. And I started by installing and importing the libraries such as Pandas, NumPys, Matplotlib, and such as sklen, Seaborn, Skitlan, and TransFlow. And the next step is data loading. I loaded the data containing S&P 500 stock data. In the data set includes important features such as close, open, high, low, volume. Yeah, I also clean the data by removing missing values to ensure better model performs. After loading the data, I perform exploratory data analysis. I calculated daily returns to understand how stock prices changes over time. I also plotted distribution of returns. Here it is. Stock prices trends of major companies like Apple, Microsoft, Amazon, Google, Meta. This helped the understanding patterns, trends, and volatility in the stock market. And the most important step in the project is future engineering and technical indicators. One of the most important step in this project is future engineering. I created the technical indicators such as simple moving average, exponential moving average, MACD, relative strength index, Bollinger Bands, and stochastic accelerators. These indicators help the model understanding market trends in momentums. I also I also created the features so that model can learn from past values. The first model, yeah, here it is. The I split the data into training and testing sets based on time. This is important because stock data is time series. Yeah, here it is. So we must train the past data and test on future data. The first model I used the random forest regression. The random forest is an assemble learning method that combines multiple decision trees to improve accuracy. Yeah, here it is shows. I optimized the model by using 50 trees, limiting tree depth, reducing computation time. I also analyze feature importance to understand the which feature have to most important in predictions. Here it is. Here show the graph. Yeah, yeah. The second model I use it LSTM, which stands for long short term memory. LSTM is a type of neural network designed for the time series data. It can remember past information using memory cells. In my implementation, I used sequence length and build compared to LSTM model. Added the dropout to prevent overfitting and use early stopping to improve efficiency. LSTM helps capture patterns over time, which are which are very useful for the stock predictions. Yeah. Now I explain how I evaluate the performance of my model. Performance evaluation. Model evaluation is very important steps because it helps us understand how accurate and reliable our predictions. Yeah, it's mean absolute error and RMSE and root square error. Here show the random forest and versus LSTM comparison. In this project, I used two models, random forest and LSTM, to compare their files performance. I evaluated both models using the same dataset matrix. And random forest, yeah, here it is. Random forest is a machine learning model that works well with structured data and is faster to train. On other hand, LSTM is a deep learning model specifically designed for the time series data, which helps it captures long-term dependence. By comparing both, I can understand which model performs better for the stock predictions. And here it is, matrix comparison of bar chart. To clearly compare the performance, I created a bar chart showing evaluating matrix of both models. Here it is, MAE and RMSC, MAP, R square. In the chart, yeah, lower value of MAE, RMSC and MAP indicate better performance, and higher R square indicate better accuracy. By visualizing this matrix side by side, it becomes easier to see which model performs better overall. And next, prediction versus actual scatter. 3,000 random samples. I also plotted a scatter graph using 3,000 random samples. In this plot, the x-axis represents the actual stock price and the y-axis represent predicted price. If this model is perfect, all points should line as a straight diagonal line. This closer the points are to this line, the better the model predictions. If points are scattered far away, it indicates prediction error. This visualization help in understanding how closely the model predictions match real values. And the next, the pre-stock timeline Apple. The future analysis model performs. I plotted a timeline for a specific stock, which is Apple. Yeah, yeah. In this graph, same the x-axis represents time, the y-axis represents stock price. I plotted both actual price and predicted price. This helps to visually compare how well the model follows real market trends over time. If the prediction line closely follow the actual line, it means the model is capturing the trends actually. This type of analysis is very useful for real world financial applications. And it shows the graph plot. And the next point is result and analysis discussions. The results shows that both model performance well, but here, yeah, random forester is faster and easier in interrupt. Yeah, here show the plot. Random forester is faster and easier to interpret, and LSTM catches time-based patterns better. Each model has its own advantage depending on the use case. And the after the next point is the main one. I also deployed the random forest model using Gradio. This allows easier to input values like price and indicators and get predictions through simple web interface. This makes the project interface and user friendly. And here show the link in Hugging Faces. And the finally save model and saving the model. Finally, I save the model, a trained model, and scalars using job leap. This allows to to be reused without returning. The conclusion: this project demonstrates the machine learning and deep learning can be used the stock price predictions. We explored data analysis, featuring engineering, and built two powerful models, random forest and LSTM. While predictions are not always perfect due to market uncertainty, these models can still provide valuable insight. Thank you for watching my presentations.